This is the center excludable rail. It's a unique feature of OMAL. When I use it, the rail is in the up position. To run a panel that is 5 foot wide for the 5 foot machine or 4 foot wide for the 4 foot machine, I simply drop it. We're going to use it because we're running small panels. We run fields T and R. The clamps are adjustable left and right easily with a quick connect jacquard handle. Okay, so now we're going to show the machine processing a panel vertically and a panel horizontally. And I'm going to mark the references so that the reference of the panel is consistent with the 00 of the machine. This panel will be placed vertical for vertical drilling. Taking the 2 00s, making sure they are at the same end of the panel. We have a panel that is perfect on the front and on the bottom. Now we're going to demonstrate running A and T with the center field, with the center field in position. Load A. This shows running the machine in alternating sequence and the productive cycle of the machine. Another testament of the machine's accuracy is to cut the ends off the two parts that we did and put one on top of the other to see the dowel length and the fact that they're all consistent. We also pointed out that the dowel stroke is measured to end of stroke. And if you look at the ends of the dowels, they are all consistent. Not bottomed on the whole depth, but almost bottomed. Lubrication system. We also have an air sensor to know that there's enough air pressure is correct for the machine operation. Here we have the glue and the dowel tanks. This is the standard system. We also have optional a high pressure glue delivery system to extract glue from a 5-gallon bucket. Here you'll notice the X-axis drive by AC brushless motor, alpha reduction gearbox, rack and pinion for quick acceleration, deceleration. Square guides for linear motion. Also we have a centralized grease distribution system with monitoring of each block for all the linear transmission. The machine has a standard manual Z-axis. This is a jacquard handle tightener. You've got a Seco digital readout that you can adjust for the height of the dowel from the table. Additionally, we use a ball screw. We can automate this axis by putting a AC brushless motor in place of the manual Seco. Tighten it down, machine holds the axis position. The dowel injector has two sensors to sense the stroke. You can see this light is lit, and when the stroke fires, it bottoms on this light, which is important to understand because the dowel is driven to a predetermined depth rather than bottoming out on the hole. The drill, the adjustment for depth is here. You unlock it, and if you want to drill 18 millimeters deep, you set it and then you lock it. Or where we have this machine set for 17 millimeters deep. The dowel revolver has three components. The revolver itself keeps the dowel held in position, ready to dowel, so you can drill and dowel simultaneously. We also have a laser that checks to see that the dowel is present, as identified by the red light. So if a dowel does not fall down this tube and into the dowel revolver, then the machine will stop and pause and give an error. The dowel revolver is actuated by this cylinder, which also checks stroke for complete rotation. You'll see these lights change hand during operation. OMAL uses a PC with Windows XP as the operating system. There are two components to the OMAL software. One is the control editor. First thing we do is specify the dimensions, make a rail that's 150 millimeters, and the length of the edge that we're processing we can program in millimeters or inches. Here's the face with a number of different ways to write to insert the drilling and doweling. We'll use single point programming, so the first hole would be 20 millimeters, and we're going to drill, dowel, and glue, and we can specify the glue time of the amount of glue that's deposited, or we can use the default. And then we'll write a new line, and we'll say, using a logical statement, length minus 20, and we'll put a drill and a dowel and glue on the opposite edge. Just making a rail, we can also specify length divided by 2 and put a drill and dowel in the center of the panel. And I changed the line of code, so now I'm going to add a new line of code. And now we have a panel with 3 drill and dowel holes. This is parametric. If I close this and change the dimensions from 150 to 200, then the new panel, the holes are consistent to the edge that they were referenced. So if you're downloading from a cabinet design package, then the machine can easily receive parametric programming as well as absolute programming. We can specify a beginning and ending point and fill the panel with holes. Let's just say 20 millimeters is the beginning point and length minus 20 millimeters is the ending point. Step is 32, and we will fill the panel with drill and dowel. So this is put as many as possible in the panel. The other aspect of the machine is the list manager and the synoptic device. Here we can control different aspects of the machine. We can open the synoptic for the head, and we can, for example, activate the dowel plunger. We can rotate the dowel feeder. We can also turn on the drill motor. Specify the number of revolutions. Activate the clamps on the machine, etc. So you've got complete control through the PC for the machine. We can also check the emergency condition if we have any emergencies, and we can run the machine in manual. The list manager can receive stack programs. We can insert, for example, the program that we wrote, rail, and specify this to be run in either normal or mirror field, or one of the 4 fields located on the front of the machine, S, A, T, and R. S is the left hand, A is the middle left, T is the middle right, and R is the right. So, for example, we could run this panel alternatingly between A and T, which would be running from the center of the machine if it's a small rail, and we can specify the number of times that we want to run this sequence at 25. Of course,